guys. So let me start the class. What I'll do actually, because we've got the presentations, I did have it scheduled in for the first few slides. We'll see how we go for the class right at the end. If we can fit it in at the end, we'll do so. Otherwise, we'll put it in the very beginning of next week, but we'll see how we go, okay? So first thing I want to just go through and click off for us is the homework part. So thank you. Most of you guys did send it all through. So thank you for that. Just Printika and Puvarna, I didn't get the homework from. Printika, are you on the call there? I don't see the camera. All right. That's all good. Everybody else, thank you so much for sending it through. We'll just run through the homework activity here. So before I run through the different ones, it's a fairly straightforward one in terms of, is the photo describing something that is a source of light or that's not a source of light? And for the ones that are sources, whether it's artificial or natural. Did anyone have any challenges or questions around this activity before I go through the answers?
No, sir.
No, sir.
Yes, sir.
Perfect. Sashwin, I see your hand.
Is the heading sources and non-sources, sir? Because I just put artificial and natural sources.
That's okay. That's fine. Did you also outline ones that are non-sources? Because not all of them are sources of light.
All right, sir.
Did you get a chance to do the ones that are non-sources, or no, just the ones that are sources of light?
No, I got it at both of them.
Okay, cool. So I'll go through these. We'll go from A all the way through to O, and let me know if you guys have any questions, agree, disagree, anything like that, and we can go through it. So glasses, it's translucent. It's just a material. It's a non-source, okay? You've then got lights. That is, of course, a source of light, but it's artificial. It's something we create ourselves. You've then got the car. So again, similar concept where the headlights are an artificial source of light. Sorry. You've got the moon, which the moon itself is not a source of light, but the reason we see it is because of the reflection from the sun, which is up here in J, which is a natural source of light. The eyes, again, they receive and perceive light. They're not a source themselves. That one's just a lake. Again, no light creation there. Lightning itself is a source of light. It's natural. It's created by the earth and the environment. Fire, of course, is natural. Candles are natural. The sun is natural. Torches, again, back to being artificial. A camera, artificial. TV.
So what does
Yes.
it say for candles, sir?
Natural.
Okay.
And the reason being is, although humans create the candle and, build it out, the flame that exists from the candle itself, that's a natural form of light. Does that make sense?
Yes, sir. Yes, sir.
Okay, cool. So just taking one quick step back. So the camera and the TV are both artificial sources of light. We've then got a mirror, which is not a source of light. It just reflects the light. And then a bulb, which again, artificial, like these ones here, and the car lamps. Any questions on this activity here? Perfect.
No, sir.
No questions. Thank you. All right. Awesome. So Ritishan, this is the section where I was going to go through the light meters and things like that. But what we'll do is, just because we're a little bit later today, we'll go through the class. If we have some time at the end, we'll come back. But something I wanted to highlight for you guys. So like you had questions last week about the clear ice or the light meters, if you can do me a favor going forward, just so we can stay on track because we only have 1 hour, just so we can stay on track for this class, any questions that you think of that are outside of the actual content, if you can pop it in our WhatsApp chat as we're doing the class, and then what I'll do is I will collate all of those, and then we can discuss them at the beginning of the next class. Does that make sense for everyone?
Yes, sir.
Okay, perfect. So yeah, any off-topic questions, I definitely want to hear it. I think it's important that we talk about it. It's definitely things that you guys would find interesting, so we should definitely discuss it. But I want to make sure that because we have such a limited amount of time, we cover the content that's already prepared, and then we can come back to it early the following week. Sarwin, I see your hand up.
Yes, I can understand. Can you tell me again?
Yes. Okay. So, last week when we were talking about light and also states of matter, we started going on a little bit of a tangent, and we started talking about the process of making clear ice and also how light meters work. So those are very good questions, but they weren't actually part of the class content for that week. So what I was saying is anything like that, I definitely want to hear it from you guys. But if you can put it for me into our WhatsApp chat, right? So anything that's not directly content related, just put it in the WhatsApp. I will then collate it, and we can discuss them at the beginning of the next week's class. Is that all right, Sarwin? Or still not clear?
Sir, I have a question. If in this class I could not understand the light, and in the end of the class I have to put in the chat that what I can't understand.
Okay, so two things. If it's content related, so say we're talking about light and you didn't understand something I was covering or something I was talking about, you can ask me right away. But say, for example, you had a question related to light, but it wasn't something I was actually covering in the class. So say you wanted to ask me about, how do light bulbs work? But we're talking about sources of light. Because they're two different things, that question, put it in the WhatsApp chat. But anything related to the class or anything I'm covering, if you have any questions, ask me right away.
Okay, sir, I understand.
Okay, perfect. Sashwin?
Nothing, sir. I just wanted to tell that Rahul is here.
Oh, perfect. Thank you for that. Thank you. Hi, Rahul. Hope you're well, mate. Thank you for joining. Puvarna, thank you. Good to see you as well. Hello. All right. So, let's get started with the presentations. So, Loka, your first one up.
Yes, sir. My presentation is about Earth. The Earth is one of planets that have gravity. What is most things have in the Earth? It is water and oxygen. There have more things, but this is two are mostly in the Earth. Why the Earth is rotate? Because of sun. Sun is attracts the Earth and pulls Earth toward. How Earth is important to us? It is have many ways.
Sorry, Loka, I'll just pause you for 1 second there, Loka. Sorry, 1 sec. Anyone not on mute, if you can just pop yourself on mute. There's a little bit of background noise. Let me see here. Okay, cool. Looks like everyone's on mute. Sorry, Loka. Continue.
It have many ways the Earth is important for us. Provides us with everything we want. This is my presentation. Thank you.
Perfect. Thank you. If everyone can jump off mute and give her a round of applause. Well done, Loka. Well done. Thank you for that. And Rahul, you're up next.
Sir,
Hello, sir.
Yes, we can hear you.
I'm very sorry, sir. I didn't get ready to my presentation.
Oh, okay. All right. I will reallocate you to another week, but please, if you're assigned the week, guys, make sure you prepare for it, okay? Because you're taking up a slot that's... Yes, sorry, go ahead.
I will prepare it for next class, sir. I will do it.
I'll let you know when, Rahul, because I already have some people allocated for next week. So I'll pop you into another slot down the track, okay? But yeah. For everyone in the class, if you're allocated, please make sure you're ready because you are taking, you're filling up somebody else's slot. So please make sure for next time. Thank you. All right. Perfect. Thank you for those guys. So we'll start with the content side of things. Now, last week we didn't get a chance to complete light. There was a couple of other things I wanted to cover. So we'll start with those ones. And it comes down to reflection and vision and how those sort of work. So the surface of all objects essentially reflect light, right? And the reason for that is if they didn't reflect light, we wouldn't actually be able to see the objects themselves. So for example, a water bottle like this one, it's not a source of light. So if this water bottle wasn't reflecting the light that hit it, we wouldn't be able to see it. Now, most objects are not shiny, meaning they're not great reflectors. The light instead gets absorbed by the object, and instead of landing on the surface, it bounces off, right? It does not land on the surface and bounce off. The light is instead taken in by the object itself. Now, smooth surfaces, for example, mirrors, windows, etc., they reflect the light very well. So when there's a smooth surface, you can see the diagram on the right here. When the light hits it, it immediately bounces off and reflects out. Now, when the surface is shiny but rough, so for example, if you take, like aluminium foil, the light hits the surface and bounces off, but that bounce off is not in a uniform direction. It's scattered, which then means the image or the reflection that we see is also scattered and distorted. So instead of seeing, for example, a clear image of ourselves, if we were to look in front of, a mirror, if we look at ourselves in front of aluminium foil that's been crushed up a little bit, you'll see your face in weird shapes. Now, the concept of mirrors and how they work in terms of the standard plane mirrors is they are glass with a thin layer of aluminium on the back, which allows for the reflection, right? So it's the aluminium sheet that reflects the light, and the glass in front is there more as a protection to stop it from, crumpling and distorting the image. Any questions before we move on? This is just a flow on from last week, just the last couple of points that we didn't get a chance to cover. Sarwin.
Sir, if we take a river and the sun is reflecting on the river and bounces off, and where does it go, sir?
So the light bounces off the water, right? And because the water is of sort of a flat surface, that's when we can see our reflection. So if you look over the water, you'll see your face. Now, in the same time, when the water ripples, because of a wave or a fish swims by or a boat goes by, you know how it ripples and it goes from being flat to being wavy? That's the same concept of the aluminium foil, where you won't see your face straight. You'll see it in, a weird shape, like it'll start moving because the surface is not flat.
like sir, in non-reflection, a spoon will come, right? It's not thin, but it is spoon. It's like it's metal, but you can see a reflection. It's like
Yeah.
scrambled.
Yeah. Definitely. Exactly right. So when the material isn't, clean and straight, as you said, it'll get all scrambled and have some sort of a distortion. Sashwin?
Yes, sir. I was going to tell that in our home, in our home, we have a kettle that we drink with it. In that kettle, if I see my face on it, it looks like googly face.
Yeah.
So, is it the meaning of the second one that the thing that are you talking about?
100%. 100%. Exactly right.
Yes.
Exactly right. Cool. All righty. Cool. So, Earth and beyond. Now, the Earth itself is almost a spherical shape. Does anybody know what is a sphere? Can someone define it for me or give me an explanation? Dinishan, I see your hand.
Spheres mean like a 3D shape, right, sir?
Yep, it's a 3D shape, definitely. Ritishan, you want to add to that one?
Yes, the sphere is like if it wants to be a sphere, all the side is a 3D shape as first of all, as Tanishan said, and from the center, everything must be like the same radius all around. And if you spin it like there's a 2D shape like this, then from the center, middle point, the radius is like 2 inches. Just imagine like that. And if you turn it like this for a long time, it will look like if you turn it like this for so fast and for so long, it will look like a sphere. And if I say so, the Earth is not a perfect sphere.
Correct.
It's actually something. If a sphere must be like this, it's like this, slightly bigger.
Yep, definitely. So bang on. Thank you there, Dinishan and Ritishan. Both of you exactly right. So a couple of points that were made there. One is the Earth is not perfectly spherical, which is why we say here it's almost a spherical shape. And the second thing is in terms of a definition of a sphere, yes, it is a 3D object. It's round. And the point that Ritishan was hitting on there was in terms of it being equidistant from the center. So that's this statement here. So it's a round, solid, 3-dimensional shape where every point on its surface, so the points on the surface, are equidistant from the center. So this side is the same to this side from the center. So that's a sphere in general. As we said, the Earth is not a perfect sphere. It's almost a spherical shape. It's close to it. But in the perfect scenario, a sphere is equidistant. The points on its surface are equidistant from the center. Ritishan and Dinishan, I see your hands still up. Just wondering if they were questions or just pending from before. Cool. Sashwin, your hands up?
I don't understand the center of it, what they were telling, sir.
Yep,
But
perfect.
I know,
Okay.
I understand the spiral. I know that thing.
Okay, good. So, the equidistant part, what that's referring to is it's explaining how. So, say, for example, we put a point here, right? And then we compared it to a point on the opposite side. The distance from here to the center and the distance from the second point to the center are both equal. So, equal distance, which is equidistant. So, if you replicate that anywhere on the surface of the shape, right? So whether the point is here, here, the distance of those points to the center of the object is the same. So this is 5 centimeters, this is 5 centimeters, this is 5 centimeters. How's that, Sashwin? Or did you need a little bit more of an explanation?
That's all right, sir. That's good.
It makes sense, yeah? Okay. Cool. Dinishan?
What is the word that eco-centers from the center? Don't know the meanings.
Yep, that's okay. So that's just what I was running Sashwin through. So say for example, okay, wait, can you guys see my camera when we're in this mode? Can you see me? Yeah?
Yes,
Okay.
sir.
Sir.
So, see this circular
sir.
shape, right? Now it's okay. See the circular shape. So from the center to this point here, that distance, let's just say it's 1 inch. Then from the center to this point here, that is also 1 inch. It's the exact same. So it's an equal distance from here to here as it is from here to here. So a sphere is the 3D version of this, right? So it's a round, solid 3D shape where every point on the surface, so every point around it, is the same distance to the center. So whether you're looking at it from this side, this side, this side, this side, all of them are the equal distance to the center. How's that, Dinishan? Does that clear it up a little bit?
Sir, Sashwin knows, sir, now. I'm clear.
Okay, perfect. If you guys have questions, please ask me even after my explanation. If it doesn't make sense, just ask me again, okay? And I'll try to do it in a different way. If you ask questions, it's better. And make sure everybody's clear and on the same page. All right. Now, a globe, which is this object here, is a spherical model of the Earth, which shows all of the land and sea covering on the Earth's surface. So everything that we've discovered as humans on the Earth, a globe is a physical representation of that. Now, the sun. Sorry, Dinishan, I see your hand up.
What is the global? What is the meaning of global?
Globe. So a globe, it's this thing on the right. Have you ever seen one of these, Dinishan?
Yes, sir.
This item here? Yep. So that itself is called a globe. So it's a model or a replication of our Earth in a spherical version. So it shows you, if you twist it and you turn it around, you will see different parts of the Earth, different countries, different oceans, all of that labeled. So that whole item is called a globe.
Oh, I already understood, sir.
No worries. Sashwin?
Yes, sir. I was going to reply to Dinishan's question that globe is the thing that like a teacher or principal or other people that has the globe in the front of the table.
It's funny you say that. I'll show you one here. I've got one.
I've
It's just
shown
not blue.
it.
There you go. So you can twist it around and you can see the different countries, different oceans. So exactly right. So it's a little one like that, like in the photo.
It's a golden, sir.
Yeah, it's a golden one. It is. It is. Alrighty. Now, the sun. From day to night, right? When we look up at the sky, what we see is the sun traveling from one side to the other and then eventually disappearing when it hits nighttime. Now, as the position of the sun changes in the sky, so does the size and the direction of shadows. I'm going to ask a question to the class. It's something we covered last week. Who can tell me how the position of the light source affects the size of a shadow? Does anybody remember? Ritishan?
like it's what's it? It's dependent on the angle of the light source. Like if the light source is right here and the object is right here, and the shadow will be like a little bit wide. If it's like this, the light source and the object right here, and the shadow will go down like a flat shadow.
Yep, 100%.
Directly under the object.
Yep, exactly right. Exactly right. So you were talking about how the angle. Hold on. Who was that one? Sarwin? Yes?
Yes, sir. As he said,
I can't hear you, mate. Bring your mic up closer. Sarwin, mic.
yes, sir. As he said, if the sun is like here, an object like that, any object like a ball, it reflects like in the middle. Like if the sun is up and it's like a house, and we cannot say it's a shadow. It's
if it's directly above, you won't see it. Exactly. So
yes, sir.
it's 100% dependent on the angle. So Sashwin, before I continue, did you have something you wanted to add?
Like everyone says, sir, that's the same. And I want to tell another thing, that the lower the light source, the longer the shadow it makes, and the higher the light source, the shorter the shadow.
Perfect. Exactly right. Thank you, everyone. Good answers from everyone. And Sashwin, that's exactly right. That's the explanation of the differences in how the angle affects the size. So as you said, the higher, the shorter, the lower, the longer. Now, for many years, back in time, humans have used this change in location of the sun to be able to tell time. Now, back in the day, people used to think that the sun itself traveled up, down, and across the sky, right? So because they didn't have an understanding of the universe as a whole, so when they just observed, what they could see is the sun rising, moving all the way across, and then setting. What we found, however, over time and through research and observation, is that what we perceive or see as the movement in the sun is in fact movement of the earth. The earth lies on an axis, and the rotation across that axis is what creates, I guess, some sort of an illusion of the sun itself traveling, when in fact it's us and the landmass that we're on that travels around that axis. Sashwin, yes?
Yes, sir. I was going to tell that example. Canada,
Just bring your mic up closer.
example, if I take Canada time morning, this is the earth, and this is Canada over here, and this is other countries. There's other countries, and this is Canada. There's sun over here. There's a sun over here, and the sun gives the light to Canada. And in like when it gets darker, the earth rotates. When the earth rotates, it comes to the other side. So the Canada doesn't get sunlight. So if our example for our country gets the sunrise, so that's why the sun, people think that sun is moving around.
Yep, exactly right. Exactly right. Dinishan, yes?
Sir, I have a little bit confusing, sir.
Okay. So, which part?
The Earth rotates axis, making it look like sun traveling across the sky
Okay.
each day.
Okay. So, you know, when you walk outside, Dinishan, and you look up at the sky, if you do it from morning to night, what it will seem like is the sun rising from one side, going to the top, and then setting on the other, right? That's what we see when we go outside. So the assumption many years ago was that the sun itself travels and moves from one side to the other. What we found, though, after years of observation and exploration outside of the world, is that it's not the sun that moves, but it's the earth rotating, which makes it look like the sun is moving, because the sun stays in one position, the earth then rotates. So if you're sitting on this country here, when the earth is facing this way, you'll get the sunlight. But as it rotates around and the sun remains on the other side, but the earth rotates and you hit this side, that's when you hit the nighttime.
I understand.
Cool.
Sir, I cannot understand, sir.
Okay. The rotation part?
Yes, sir.
Okay. So what I'll do, maybe I'll use this one here. Okay. So you guys see the globe that I have here, right? Now, let's say, for example, the sun is behind me. That means any of the countries that are on this side here are going to be nighttime. As these countries then switch to the other side where the sun is, that's when it becomes daytime. Right? Because the sun itself doesn't move. It's the earth which is rotating that makes it look like the sun is moving when we look outside throughout the day. But in real fact, what's happening is the earth is staying in one angle on its axis, and over the day, it's rotating. So we start at point A, and throughout the day, as the time goes on, we rotate all the way around till we come back to the same point, which is the next day.
Okay, sir, it makes sense.
Cool. Loka?
Sir, the Earth is how many hours the Earth is rotating?
Yes, good question. So the rotation along its axis takes 24 hours. That's why we have a day and a night, right? So in one full rotation, we will experience everything from 12 a.m. all the way out to 11:59 p.m. because it goes from start to finish, and that takes the 24 hours. Ritishan, question?
Question, sir.
I can't hear Ritishan. Sorry, I can't hear you, mate.
Can you hear me now?
A little bit. Yep, go ahead.
Actually, the Earth spins for 23 hours and 53 seconds.
Good. Yes. It's a very good point. Which leads to my next point here about the rotation. It's on the next slide. But yes, it's a very good point because it's not a full 24 hours, just like it's not 365 days for it to orbit the sun as well. So it's a good point. Yes, Sashwin?
I think in an hour, I think the sun moves slowly in an hour. So that's why in 24 hours it becomes when in Indonesia is morning time. I think for 1 hour the sun moves and moves, and in 24 hours it's become a daytime, like you said.
I'll just stop you there, Sashwin, because there's one important change you need to make to the statement, and that is that the sun does not move. It's the earth which is rotating, right? The earth is
Sir, I just
rotating
made
on
a mistake.
its axis. Sorry?
No, I just made a mistake.
Yes, yeah. That's fine. No problem at all. I'm just wanted to clarify that it's the earth rotating on its axis, which moves us from one side to the other throughout the 24 hours. Now, I do see a few hands up, guys, but I'm just gonna power through because it's almost it's already 9:42. Oh, sorry, yeah, 18:02. So let me go through and pop any questions you have in the chat. Okay. Now, the sun itself is at the center of a group of planets. This arrangement is referred to as the solar system. Now, the Earth is not the largest planet, nor is it the closest or furthest from the sun. And what you can see here is a sort of a picture of what the solar system might look like. Now, none of these are to scale, but it shows you how the Earth is not the closest to the sun, and it's also not the biggest planet in the solar system. Now, each planet travels around the sun in something called an orbit. Loka, I see your hand up.
Sir, but I studied this, but the planet is 8, but there have is 9, sir.
Yes, because I believe Pluto has been removed as a planet. So I don't believe Pluto is recognized as a planet anymore. So you're exactly right. It's 8 now. So this photo is a little bit outdated. Good catch. Good catch. Now, each planet travels around the sun in a pathway, and that pathway is called an orbit. Every journey roughly is a circular one, and that full journey is referred to as a revolution. The Earth moves in 2 ways at the same time, right? So the first is we were talking about the rotation on its axis. So it's on an angle, it's rotating on its axis, which what creates us the day and night. And then there's the revolving around the sun in an orbit. Now, the orbit, like Ritishan mentioned before, although we say, a day is 24 hours, it is slightly shorter. And in the same premise, a year is not exactly 365 days. It's 365.25, which is 365 and a quarter. So the way we make up that difference is we have 365 days in a standard year, and then once every 4 years, we have a leap year, which has 366, because each year has a quarter day. So when you add 4 of those, that makes 1 full day. So the 4th year, which is a leap year, is the one with 366. Sashwin, I've seen your hand up. You have a question, mate?
Yes, sir. I was going to tell that like you say, but when the Earth rotates, it also revolving. I was supposed to tell in the beginning, but I forgot to tell it.
No worries. Yeah, good point. Exactly right. Yes, definitely. There's two movements happening at the same time. Now, as we mentioned before, Ritishan, yes?
You told that 1 year completes at 365.25, right?
Mhm.
But that is not what I mentioned. I mentioned a different one, which is like in a day.
Yes.
In a day, there is 23 hours. Sorry, 23 hours and 53 minutes. That is what I mentioned.
Yeah. All I meant by referring to that point is, Ritishan, I was saying it's a similar concept where although we say 24 hours in a day, it's not exactly 24. And you know how normally we say it's 365 days in a year? Similar concept. It's not exactly 365. There's a little bit extra that we adjust for over time. But you're exactly right. Good point. Dinishan, you have something, mate, before I move on?
What is revolution, sir? What is the meaning of revolution?
Of revolution? This one here? Yeah. Sorry, can I get you on mute, mate? There's just a little bit of background noise. Okay, so the revolution refers to the planets going around the sun. So not the planet rotating on itself on the axis, that's the rotation. The revolution is it when it travels, you can see in this photo here, as it travels around the sun and comes back to its original position. So that travel takes roughly 1 year for it to go from one side of the sun all the way around and back.
Okay, sir, I understand.
Cool.
Sir,
Sorry,
do you know? One day, the scientists said in YouTube there is one day that already 25 hours. It's a 25 hours.
Yep. So one of these definitions, so these points, if you guys can pop it in our WhatsApp chat so we can discuss it next week, right? So this is just a good point. It's a nice example of something that's definitely I want to discuss, but it's off the content here, so we'll come back to it next week. So if you can pop it for me in our chat, we'll come back to that one. Okay, cool. Now as we were saying, the sun the earth.
Sir?
Yes, mate, Sarwin, yes.
I didn't understand that, sir.
Which one?
The 335.25 radiation in the year.
Yep.
365 days in the sun. I can answer that, sir.
Yeah. Okay. Cool. So, you know how in 1 year, Sarwin, do you know how many days in the year we have roughly?
What, sir?
How many days do we have in the year roughly? How many days do we usually say?
We usually say.
Yeah, so generally, right, the general rule is that there's 365 days in a calendar year. So for the Earth to do one full revolution around the sun, so not rotating on itself, but revolving around the sun, for it to do one full one, it takes 365.25. Now, the 0.25 is 1/4. So if you have 4 of those, that equals 1 whole, right? So for the first 3 years, we say there's 365 days. But in the 4th year, which is a leap year, we say there's 366 because there's the remaining 0.25 from the first 3 and the 4th year together makes it 1 full day.
Okay, sir.
Cool. Now, what I'll do, we are short of time, so what I might do, I'll skip through these ones, and we'll just jump to the end of the lesson. So guys, as always, Sashwin, yes?
I wanted to tell that Neptune is a cold place, a cold
Hold on, Sashwin,
planet.
sorry. If it's not a question, mate, I might get you to just hold on to that one. Just because we're running a little bit short on time, and we'll come back to it, okay?
All right, sir.
Thanks, mate. So these ones, guys, the slide deck, I'll put it in our WhatsApp as usual, okay? Just scroll to the end of the deck and you'll be able to see the homework activity. Let me know if you have any questions. Now, with the presentations, Next week, we have Sashwin and Puvarna. Okay. So both of you are on the call. I know Sashwin's on here. Puvarna, you're there as well. So just letting you know for next week. Okay. Please have your presentation ready. Now, as I said, roughly about 3 minutes. Okay. We want each of the presentations. I want you at the beginning to outline the title and introduce yourself. Okay. Say your name. And then just to help you with the presentation, use the what, why, how method. Okay. Now, there's an example here which you can look back to on the slide deck. So now that we're through that, or any questions before I start up the Kahoot around the presentations and things like that?
So I don't have any questions. I don't have any questions about the things we studied, but I want to ask, can you give us the questions in different ways? I mean, like in Kahoot, there is, I mean, only in Kahoot, I mean, there is tallest tower and chill, what's that? Chill painting, like that, right, sir? Can you give us from that? Or
Yeah. Good. Yeah, absolutely. Open to suggestions. If you want to just put it in our WhatsApp chat for me. Anything that you want to see happen in the classes, any suggestions you have, please put it in and I'll have a look into it for you. Definitely. Good one.
Okay, sir.
Thanks, Ritishan. Please put it in and I'll definitely look at it for you. Let me find
I think
out.
we misunderstood, sir.
Oh, sorry. Yeah, go ahead.
I mean, in the Kahoot game, when you want to host one game, there will be like which mode you want to play, like the 2 towers, casual.
I see what you're
like
saying.
that.
Yeah. So instead of the classic mode, to do the other modes.
Yes, sir.
Okay, cool.
Try that.
Definitely.
Yes, sir. I think you might do that. That's cool.
Okay. Sure, definitely. I've popped the code in or the pin, for this one into our chat if you guys want to grab that and log in. But yes, definitely. I'll look at the other game modes for the classes going forward. Good point. Perfect. There we go. I can see everybody in there. So let's start. All right. Now back into today's class questions. Oh, Loka came in right there. Second place. See, last question. All right. So, Sarwin, Loka, and Ritishan, I believe. Well done, guys. Well done. If I'm not wrong, you guys keep winning the podium week on week. That's pretty awesome. We need somebody else challenging them and taking on the top spots. But well done to the three of you. That's really good effort. Well done. That brings us to the end, guys. Any questions before I close off? I know we're already a little bit over time, as usual. Any questions before we close off for today? Dinishan, I see your hand up. No? All good? No worries, guys. Thank you so much. No worries. I'll see you next week. And as I said, any points that you had during the class, I know I cut a couple of you guys off. Please just put it in the WhatsApp chat and I'll cover it, or we can cover it early next week. And Ritishan, I'll make sure we go through the clear ice and light meters. I'll pop that in the beginning of next week's lesson, okay?
Okay, sir.
All right, guys. Cool. I'll see you then. Thanks so much. Bye.
Bye, sir. Thank you, sir. Bye, sir.
No worries.
Have a great day.
Bye, sir.
It's okay.
Thank you, sir.
Bye,
sir.
Bye, sir. Thank you. Have a great day.